Hello everyone, welcome back to my channel Shraddha's Physics. Today we will discuss about simply connected region and multiply connected region. Before going to the topic, let me tell you what is a contour. So a contour, it is an arc which consists of finite number of smooth arcs. They join end to end. So basically we can say that this is a boundary or the side wall of any figure. This is called a contour. Then what is a simple closed contour? When a simple closed contour means it is simple closed contour. So a simple contour is called closed when the initial and final values of some complex function, suppose z of t, it coincide. It means that suppose I am drawing a triangle, its initial point is this. If I will start from this point and at the end I will reach at this point, so the starting point and the ending point, it will remains the same. It means that a simple contour is called closed when the initial and final values of any function z of t, suppose it coincide. It may be of any shape, triangle, circle, any shape, square, hexagon, pentagon, polygon, etc., whatever it may be, but the condition is that the initial and the final values must be coincide. Now we will see what is connected region. Suppose I am considering any region, any shape, this is any region R. This region is called connected if any two points, if I will consider in this region, if any 2 points of this region are, it can be connected by a curve which lies, it may be any type of curve which lies inside that region. Then this will be called connected region. It means that you can see that this curve which connects this region, it lies entirely inside that region. That is why it is called the connected region. This connected region is basically of two types. One is simply connected region and other is multiply connected region. First of all, let us see what is simply connected region. Suppose I am drawing any type of region. Suppose first of all I am drawing a circle. This is suppose region R. This red one is called suppose region R. This region R is said to be simply connected if any simple closed curve, suppose this is any simply closed curve C. This closed curve C, it lies inside this R. You can see that here this curve C which lies inside this R, it can be strong to a point without leaving R. It means that it will lies inside this region R. So we can say that all the closed path within the region R, it contain only points belonging to that region R. That is a region or domain of a function in which the function is analytic everywhere and the closed curve, it can be strong to a point without leaving a hole, is called a simply connected region. Now I think it is clear. Now we will see multiply connected region. We can say that a region R which is not simply connected region, that is called the multiply connected region. Suppose here I am considering this is the larger circle is mod z equal to 2, this one is the radius and the smaller one have the radius mod z equal to 1. Suppose I am drawing any closed curve here, this is suppose C. You can see that it lies inside the R. You can see that this one, this black one, okay, it cannot be possibly strong to a point without leaving the R, okay. So that region R is called, that is why the multiply connected region. So one can say that in a multiply connected region there are a large number of holes inside it, whereas in case of simply connected region there are no holes. So you can see here that this is suppose C1 curve, this is suppose C2 and this one suppose C3, okay, and the larger one, this one is suppose C, okay. So here you can see that here there are 3 holes inside this multiply connected region. Again, if the region or the domain when strong, it leaves any holes or cannot be strong to a point within that closed curve, it is known as the multiply connected region. or you can say that in a multiply connected region, the function fails to be analytic at some points within that domain. If the domain of the multiply connected region is finite, then the curve is called the finite multiply connected region. Here you can see that here there are three regions, that is C1, C2, C3. These are finite in number, so that's why it is called finite multiply connected region. Similarly, if the domain of the function is infinite, then the function is said to be infinity. Matlab, it is called infinite multiply connected region. Okay. Here you can see that there are different types of curves here. This is suppose 1, 2, 3, 4, 5. Okay. So from this you can see that this 1, 2, 3, these are called the simple closed curve because it doesn't cross itself. If the curve crosses itself, then it will call the multiple curve. So here you can see that the figure 4 and 5, these are called multiple curve. Now we will see how this multiply connected region, suppose this is any region R and these are any closed curve, suppose inside this multiply connected region, suppose C1, C2 and C3. Okay. So this multiply connected region, it can be converted to a simply connected region by adding some lines. Suppose I will draw, these are called the cross cut. If I will join this curve C1 to the region R and simply I am drawing two parallel lines from C3 to R and here also from C2 to R. If I will start from the C1, this is my arrow direction and we will go from C1 to region R1 in this direction, and suppose at some instant I will reach at C3 curve through this parallel line. Again crossing this curve I will reach at this parallel line and again I will be at here in the region R, and then to reach at C2 we will go through this point, go through this path, and again after passing through this C2 curve we will reach at this parallel line and again we will reach at this region R. So here you can see that while starting from this point, if I will join these all lines, you can see this red line, just try to follow me in this way, and again I will cover this path and same I will reach at this point, okay, from where I have started. So here you can say that this multiply connected region can be converted to a simply connected region by doing some cross cuts. These are called the cross cuts. These parallel lines are called the cross cuts. Okay. So here there are some conventions regarding traversal of the closed path. Here you can see that while going from right to left, if you will consider this as positive, then definitely from left to right direction you will consider this as negative, or vice versa also true. Okay. Suppose the integration of f of z around any boundary, suppose this boundary is C, in the positive sense, so it will be denoted as f of z dz integration over the closed contour C. Okay, so this integral around the C, it is called the contour integral. This is called contour integral. Okay. So this is all about simply connected region and multiply connected region. Just try to watch the previous lecture, that is the integration of the complex number or the complex integration. If you have any doubt, just try to watch this video from the beginning, or still if you have any query, can ask me in the comment section. So this is all for today. Thank you.